Hello friends, welcome to my channel. Let's have a look at a newly appeared problem, problem 2599. Make the prefix sum non-negative. In this video, we're going to explain a solution with the help of heap. So heap is an abstract data type. So here in this problem, we are given a zero-indexed integer array called nums, and we can apply the following operation any number of times. Pick any element from nums and put it at the end of nums. So the prefix sum of some array of nums is an array called let's name it as prefix of the same length as nums, such that prefix I is the sum of all the integers nums g for g from the beginning up to index g. So we are required to return the minimum number of operations such that the prefix sum array does not contain negative integers. So here, this last sentence is very crucial. It's actually very important. So the test cases are generated such that it's always possible to make the prefix sum array non-negative. So this basically determines how we do the coding for this problem. Here are two examples. In the first example, if you compute the prefix sum, you get 2, then 3 plus 2 is 5, then 5 plus negative 5 is 0, and 0 plus 4 is 4. So this is the prefix sum, so we don't need to perform any operations as specified in the main statement. So in the second example, so as long as we put the negative 5 to the end, so we're going to have 3, negative 2, 6, and negative 5, because this guy is large enough. So basically we have 3, and the 3 plus negative 2 is 1. So 1 plus 6 is 7. Then 7 plus negative 5 is 2. Therefore, we just need one operation in this problem. So if we do not perform this operation, because 3 is too small compared with negative 5, in order to make it sum to a positive number or non-negative number. So 3 plus negative 5 is negative 2, right? So with that said, let's look at the constraints. So the constraints are actually the additional assumptions for the problem. So here the list nums is not empty, and its length can be up to 10 to the power 5. So this number is a decent large number. And secondly, so the elements in the list can be negative, can be 0, and can be positive, but they are bounded in absolute value by 10 to the power 9. So with that said, we are ready to look at the analysis. So this problem actually is very easy in some sense with this sentence here. Here our treatment is based on a linear scan, but we want to use a heap to retrieve the minimal elements from the list nums we have seen so far. Let's make it more formal. So here the idea is that we compute prefix sum by linearly scanning the list nums. And then we're also going to record the smallest value in the nums list up to now. So by recording the smallest value, basically we need to be able to retrieve the smallest value before. So this can be easily done using the heap, right? So there's an implementation in Python called it's basically a min heap. So once we meet a negative prefix sum, we are not going to use that sum. We adjust the value. So here this value means the prefix sum by subtracting the smallest pre-seen values from the nums list. So this in effect plays the role of moving a previous negative element to the end, right? So this way we just need to do a linear scan to check how many operations we need. Here I want to mention this note again. So the test cases are generated such that it's always possible to make the prefix sum array non-negative. So this is an important one, actually an essential one. So here the thing is that, so in the process of doing linear scan, if we see a negative prefix sum, so we adjust that sum by subtracting the most negative elements in the up to now in the list. So if because we are making the smallest number to the end of the list, so all the previous prefix sum will maintain a non-negative or even larger because we moved the smallest one. We always do this in the process, and then we can guarantee the soundness of the procedure. So with that said, basically that's the above explanation is a high-level overview of the whole procedure. So if you are interested, you can look at example 2. So here we're going to use S, basically is the prefix sum, heap is a heap, and the result is the number of operations we need to use. And then basically for each index, we record the state of S, each, and then heap, and the result before this index. We just entering this iteration, and after that. So then basically for this example, we're going to return 1. So with that said, let's specify the code. So after we specify code, actually we can print out this information to help you understand. And actually, it's always good to first get the overall big picture, and then digest the code, and then go into details of the code. Actually, there's a lot of things can be digested in the process. So with that said, let's first initialize a result variable. So it's going to be used for counting. So its final state is what we want to return. So S will be the prefix sum. So and each heap. So I'm going to use a heap represents a heap. So let me make some annotations. So here step 0 preparation. So here let's see counting purpose, right? And S prefix sum and heap to record the minimal elements, right? So this way we can easily retrieve the minimal elements, because in min heap the heap at index 0 will correspond to the smallest element, or you can just use heap pop. So this is the first 0 step. Then step 1, so we're going to do linear scan. First, I'm going to just iterate without involving the index, and then I'm going to add index and then print out some information. So for y in nums, so basically we increment this s by y, right? And then what we're going to do is to heap q, heap push. I'm going to push this y to the heap. Notice that we are pushing the elements from the nums into the heap, not the sum. And then what we are going to do is to check if s is negative. If s is negative, it means that the current number y is just pushed is to negative. Basically, you can understand this or use it as a heuristic. Then we need to revert to the previous state. Basically, heap q, heap pop. So pop from this heap, we're going to get the smallest element. Then we recover the previous state. So once we do these operations, we can imagine we put this guy at the end of the nums array or list. So this way we are going to increment the result or the counting by 1. So that's it. Then notice that the test cases are generated such that it's always possible to make the prefix sum array non-negative. Then we don't need to worry about the soundness of the method. So what we are going to do is to return, right? So we're going to return the result state. So this small piece of code actually forms a solution format to this problem. So before we do anything or comments, let's first make some tests. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So let me copy this one here. So this is the method or the code we are going to share. And but let's put this one into V1. So here I want to iterate with index. Here I'm going to print out some information for us to help us to understand, right? So here what I can print is that, so let's see, I'm going to use fstring. So current ID, let's see, is I, right? And then what we're going to do is so before entering this one, what we get. So basically I want to print the state of first s, right? So let's see, s equals s, and the heap state. So basically I'm going to write it like this, heap, and also I'm going to print out the result. So this is the one, and then afterwards, after we compute the prefix sum and do the adjustment, and then also in s and in the result, let's print out these things again. I don't need this line. So basically, this is the after finishing this right. So what we're going to have is like this. Let me print a empty line. So this will give us the information about the running result s and the heap. Let's see. Yeah. So this is the state for the first example. Now let's use the second example to do a digest. Yeah, so this is just before, right? After we get 3, right? This is the heap state, the result. Then after we get the first one, so we're going to get this one afterwards. So the result is 1. So then it remains 1. So this is the final stage. So with that done, basically that's about it for this specific problem. So if you find this this video useful, you're welcome to share or distribute, and also you can follow us in this YouTube channel for more practice about leetcode problems and other algorithms. So with that said, I guess that's about it for this video. Thank you.